Honestly, I want to see everyone succeed. This is all extremely cool stuff, really innovative technology, and the harder everyone pushes each other, the more successful we all are.
We are trying to develop and test tools to enable students to tackle complex autonomy tasks with drones.
Today we're at the Timpa Airfield in Tucson, Arizona, here for NSF CPS VO Challenge, search and rescue. So basically the goal today is to autonomously detect and pick up an object and deliver it to another location. So that's what we're here for.
A program like this allows the students to address both hardware and software in a setting where the problem is challenging, and as we are trying this competition, starting with a pilot, we are developing the right tools to enable them. So it's together students learning how to address drone autonomy and also helping us to build better tools for them.
So my degree is in computer science. Really, without NSF or other programs like this, I wouldn't have much experience with hardware as a whole. And I really enjoy being able to write software code that moves something in the physical world, other than electrons in a CPU. So that's been a really kind of unique experience.
I think one of the main challenges out here is the differences between simulation and the real world. So everything works in simulation, but when you come out to the real world, sometimes you tell your drone to do something and it doesn't do that thing. So the challenge is how do you debug? In most applications, most of it is debugging and figuring out what your errors are rather than actual development.
Yeah, so there are many drone competitions. They are funded, a lot of industry funding, and they are usually structured around solving a very specific task. Usually, they'll be challenging, but it won't have autonomy challenges similar to ours. So given the complexity of the task that we are throwing at the students, which actually derives from science goals, like can you monitor pests in a farm with probes, teams are better prepared for the kind of autonomy that we are imagining systems of the future will need.
This competition, I think, is by far the best with that respect. I think the rules are phenomenal. I think it's really cool that you get 3 days to kind of test and tweak your solution, as opposed to, like a single make or break test flight where anything could be happening. Maybe you get 40 miles an hour wind and the guy right after you gets nothing to deal with.
That was a little rough.
And ideally, next year I would want to come back with a better design, more improvements, better refinement, and I just want everything to be as best as it can possibly be.
I think this competition is very interesting in that, one, it's an application of just autonomy in any way, and I think there's very interesting aspects of that will be very beneficial in the future. If we can come up with safe ways to do reliable autonomy, then I think in the long run, it'll be better for all society.